Supplemental math videos from Circle Christian School.
Will they go around in circles? This is all about circles. They're round. They have no beginning. They have no end. They do have two sides, though. First, we have to start with the different parts of a circle. Let's see, I forgot to put the little circle here with the dot. So there's your little tabby. All right, the first one comes from the center of the circle, and it is the radius. This is the thing that you're probably going to lose the most of. You have in a circle, and I guarantee you, you're going to lose that radius. The next one is when a radius connects all the way from outside to outside of the circle, and that's called the diameter. Two radii make a diameter. A diameter is a line that goes across the circle and through the center. A chord is a line that does not go through the center of the circle. A secant, or second, depending on what part of the country you are from, is a line that goes through a circle. And last, a tangent line. Yes, it does have some properties of trig going on here, but a tangent line is a line that hits the circle at exactly one point. That point is called the point of tangency. Now, what's important about this point is if you draw a line from the center of the circle to any tangent point on the circle, it will always meet at 90 degrees. See where the tangent's coming in here? There's that right triangle. Okay, a couple of fun lines that happen in and around circles. For instance, this line here is what we call a internally tangent line that connects two circles at their point of tangency. But notice it is on the inside compared to this line, which is an external tangent line because it connects on the outside of the circles. Circles can also be tangent to each other at a point of tangency. It's just where a circle hits another circle that creates that point of tangency, a point that connects them. So let's find the area of water fun for this toy boat. All right. Seeing that we have a right triangle made out of a tangent line and the radii of the circle, we're going to take our first leg, which is our 25 feet, and we're going to square it, and add it to our second leg, which is our radius, squared, and it's going to equal our hypotenuse, which is actually r plus 15. And we square that. Do be very careful here because the binomial r plus 15 is actually a parentheses squared. So it's actually r plus 15 times r plus 15, the binomial squared. 25 squared is 625 plus the r squared. So we have to do that little foiling thing, or if you're pretty quick here, you'll remember that there's a quick way to do this, the 5-second way, and it's always the first one squared. The middle part happens twice, so that's going to be 30r. Plus the last one squared, 15, which is 225.
And we just fill out the rest of the problem. Now, basically, we have to get some sort of r all by itself. And the handy person will notice, hey, on both sides of the fence here, we have an r squared, which would just cancel each other out. And so I want to get the 30r all by itself. And so we're going to take away the 225 from both sides. And that's going to leave us with 400 equals the 30r. And now we're going to divide out our 30 . And r is going to equal, and we can get rid of the zeros there, 40 over 3, or 13 1/3 feet of fun for our boat to float around on. All right, go grab yourself a toy boat, put it in the water, and see where the wind takes it.